Hi, Algebra 1. Here we go with lessons 6 and 7. We're going to be continuing with our area models, but now we're going to be focusing more on the signs, so positives and negatives. Here we go. First thing in number 1 here, y times 5 would be 5y. We usually put that number first. And then 5 times negative 9 would be negative 45. So if I write out my final answer over here, I would have 5y minus 45. So the signs are going to come in here where we need to keep track of positives and negatives. Remember that a negative times a positive is going to be a negative. On this next one, 3k times negative j would be negative 3kj, because again it's a positive times a negative. And then 4 times negative j would be negative 4j. And so my final answer would be negative 3kj minus 4j. This first one is really similar to those previous two that we did. This one over here, we need to be careful when you take negative 7 times negative m. It's going to be a positive 7m. And so you see that there in your final answer. In number 7, number 6 is what you end up with right here. And writing out your answer, you're going to have 4d, and then you'll have your negative 28 minus dm plus 7m. The one at the end there might be tricky because that's where your 7m needs to be positive. Negative times a negative gets you a positive. In number 7, go ahead and try this one on your own. And this is what you end up with. We'd have negative 6k minus 3n plus 15. Remember, negative times a negative is a positive, and a negative times a positive over here is going to get you a negative. On the next page, I introduced some vocabulary at the top, so I want you to highlight or underline this. Terms are part of an algebraic expression joined by addition or subtraction signs. And then they give you an example. In negative 3x plus y, the negative 3x and the y are terms. So number 10, how many terms are in the expression 4x plus 5yz? This is a term and this is a term, so there are 2 total terms. In number 11, there is just one term, because it's just one piece. They're all being multiplied, but there's no addition or subtraction signs. In number 12, there are 3 terms, and in 13, there would be 2 terms. The number of terms is important because in number 14, if we're going to use an area model to multiply this, we need to know how to split things up. So a minus 6 has 2 terms right there, and then 2b plus c minus d has 3 terms right there. So when you use your area model, it depends, what it looks like depends on the number of terms. After I multiplied everything out, I would add all of those pieces in the table together here, and this would be my final answer. I know it's really long. It has 6 terms in it, but that would be the answer. Number 15 is also giving us some vocabulary of like terms. And we're saying that like terms are terms that are alike except for their coefficient, the number part, and they can be combined. You've seen this before. If we have 10 xy's in a table like this, there's 1 in each box, they can all be combined into 10 xy. If we use an area model that's actually partitioning out things a little bit more, we can see that like terms end up with the same shape. In this one, the x squared is a big orange one. Then we have 4x and 3x right there. And so that would be a total of 7x. Those are like terms and they can be combined. In number 17, let's focus on the ones here on the screen first. We're going to look at which ones have like terms that can be combined. So a has 3x and 5x. They have the same variable, so they can be combined into 8x. B has 7w and 2w. Negative 2w, those can be combined, and that would be 5w, because 7 minus 2 would be 5. F is not like terms. 6 plus x cannot be combined because they do not have the same variable. 6 has no variable, and x has a variable. In G, those can be combined. That would be 7x. In math, this really means a 1 there if there's nothing in front of x. And so you have 6x plus 1x is 7x. In the next part, the only ones that have like terms are going to be D and H. In D, I have 2w and negative 7w. If I combine those, it's like 2 minus 7, which would be negative 5w. And in H, remember there's like a 1 here. So this is 5xy minus 1xy, so that would be 4xy. Moving on to lesson 7, now we're going to see even more of the area models show up. And here they're showing x plus 3 times x plus 3. X times x is going to be x squared. Notice that they show this with an actual square, because you think of area, length times width. Well, if that length and width are the same, they're both x, you end up with a square. Then we're going to look at these terms here, 3x and 3x. Those can be combined into 6x, and then we just have plus 9. In number 2, now we have 2x times x. Well, that's going to be 2x squared, because you look, you have two squares, and they're both x squared, so you have two of them. Then 2 times 2x is going to be 4x right there. X times 3 would be 3x right here. And then lastly, 3 times 2 would be 6. And so when I'm writing my final answer, I only have these 2x squareds, but this 4x and 3x are like terms, so they could become 7x, and then I have plus 6 at the end. Number 3 is a little bit bigger. We'll start up here in the corner. X times x would be x squared, and then going across, x times y is going to be xy. X times 2 is going to be 2x. The next row is all done for us, just some different variables. Here's a y squared. Right here, 1 times x is going to be x. I'm going to write it below. 1 times y is going to be y, and 1 times 2 is going to be 2. So now writing out our answers here, we're looking for like terms, and I'm going to color code them. So xy and xy are like terms, so when I'm writing my answer, I have 2xy. Plus, I just have 1y squared, but I have some more like terms here with 2x and x. That's going to be a total of 3x. And then I have a total of 3y. Again, there is 2y and 1y. And then I have 2 at the end. So this is the final answer. In number 4, this is what we end up with, and we're looking for those like terms again. I see 4x and 5x, those are like terms. And so when I write my answer, I have x squared here. I have a total of 9x, and then plus 20. In number 5, when I multiply with my area model, that's what I get. And I have some like terms. There's 5y and there's negative 8y. So when I write my final answer, I have y squared minus 3y, and that came from combining 5y and negative 8y. And then I have minus 40 at the end. In number 7, we see that b squared come up again. We have 7b and then minus b squared, because we have a negative times a positive. And so there's our final answer. Here's my area model when I multiply, and I do see some like terms here with 7b and negative 7b. Now 7b minus 7b is just going to be 0. So my final answer is going to be negative b squared plus 49, and that's it. Skipping down to number 13, we have a problem that was done using an area model, and we're trying to figure out what were they working on. And so I see on the top r plus 9, and then I see going down the side r plus 9. Now those are the exact same thing, so I could rewrite this as just r plus 9 squared, because that means r plus 9 times r plus 9. And my answer would be r squared plus, I have some like terms right here, so that would be a total of 18r plus 81.